Good morning, children. We are doing the P block elements, and in this P block elements we are doing group 15. We have already finished with the physical and chemical properties of group 15 elements. We are going to start with the anomalous properties. We are going to discuss the anomalous properties of nitrogen. Now, what are the anomalous properties of nitrogen? Now, why does nitrogen show anomalous behavior? What is the reason for it? Nitrogen is the first element of its group, so it has exceptionally small size. So this is one of the reasons why nitrogen shows anomalous behavior. Second is the high electronegativity. Now, the most electronegative element is fluorine, then oxygen, and then nitrogen. So it is highly electronegative. Then the third point can be it is because of the high ionization enthalpy which nitrogen possesses. And the fourth point being that d orbitals are absent. The vacant d orbitals are absent in case of nitrogen. So these are the reasons why nitrogen shows anomalous behavior. Now, what are the anomalous behavior which it is showing? First point being the p-pi multiple bonds. Nitrogen forms p-pi multiple bonds, and these p-pi multiple bonds are because of its small size and high electronegativity. Now, if you compare it with the other elements, nitrogen is very small in size, so it forms strong bonds, p-pi multiple bond. It exists as a diatomic molecule with a triple bond, one bond being a sigma bond, and the two bonds are pi bonds between the two nitrogen atoms. And the nitrogen molecules, they are held by weak van der Waals forces of attraction, which can be easily broken by collisions of the molecules at room temperature. Therefore, we can say that nitrogen is a gas at room temperature because molecules are held by van der Waals forces of attraction. Now, nitrogen, as we can say that if you compare the other nitrogen with other elements of its group, they are large size, they are held by covalent forces, and that is why they do not exist as gas. The attractive forces are quite strong, and they cannot be broken by collision of molecules at room temperature. So the bonds are quite strong. So that is why they exist as solids at room temperature. Now, the second important property about nitrogen is the self-linking of atoms, that is the catenation. Now, the property of catenation is seen in nitrogen. Now, the reason being that the bond between the two atoms is much lower. Now, if you look at the bond strength between the two atoms of carbon and the bond strength between two atoms of nitrogen, the nitrogen will show lower bond strength, and two carbon atoms will show a higher bond strength. So these elements, they show property of group self-linking property which is much smaller as compared to that of carbon. They show catenation, but it is limited only to 2 or 3 atoms. So nitrogen does not, it shows catenation but only to 3 atoms. Then the reactivity. Now, the triple bond in nitrogen, the bond length is small and the dissociation enthalpy is very high. The bond length is small and the dissociation enthalpy is quite high. Now, due to the presence of this triple bond between two nitrogen atoms and the bond dissociation energy being quite high, the nitrogen molecule is quite inert and unreactive, and therefore it is more in its elemental state. it is very unreactive because the bond dissociation enthalpy between two nitrogen atoms is quite high. So it is very inert and unreactive. Now, in case of phosphorus, the bond dissociation enthalpy is much weak because the two phosphorus atoms are quite big than the two nitrogen atoms in the triple bond. Therefore, phosphorus is much more reactive than nitrogen. And this reactivity of the other elements, it decreases down the group from arsenic to bismuth, etc. Now coming to the maximum covalency, nitrogen is an element of second period. It has only s and p orbitals and no d orbitals. Therefore, we know it will not form pentahalides. Nitrogen does not form NCl5, but phosphorus forms PCl5. Why? Because d orbitals are absent in case of nitrogen. Nitrogen can show a maximum covalency of 4, and 4 when it donates its lone pair of electron, as in the case of ammonium ion. Nitrogen cannot expand its covalency beyond 4. That is why it does not form pentahalide. Whereas phosphorus and other members of the group, they have empty d orbitals, they have vacant d orbitals, and they can exhibit covalency beyond 4, that is 5 and 6 is also seen in case of phosphorus and other elements. Now, d pi p pi multiple bonds, due to absence of d orbitals in valence shell of nitrogen, they cannot form d pi p pi multiple bonds, whereas phosphorus and other heavier elements, they can form. Because of its high electronegativity, it is the most non-metallic element, and as you move down the group, the metallic character increases. Now, oxides, nature of oxides. Nitrogen forms different oxides, about which we have already done. Oxides in which oxidation state ranges from +1 to +5. The N2O, NO, N2O3, NO2, N2O4, N2O5, etc. These are the different oxides of nitrogen, and they are monomeric in nature. Phosphorus forms oxides which are dimeric in nature. Similarly, arsenic and antimony also form dimeric oxides. Bismuth, of course, it forms one monomeric oxide, which is Bi2O3. So these are some of the anomalous properties of nitrogen. I hope I was clear. Thank you.